welcome to Pre-Cal Lecture 1.9a. This is called Section 1.9 is about factoring patterns. And this is a short little lecture that we will continue with 1.9b on the next one. So Section 1.9.1 is called Factoring Perfect Square Trinomials. So if we have a plus b all squared, so that's the same as a plus b times a plus b. And if we FOIL that, we would have a times a, so that's a squared, plus ab plus another a times b, so that's plus 2ab, and then finally plus the last, b times b is b squared. So we're just FOILing that out. And if we had a minus b all squared, that's going to be a minus b times a minus b. And if you FOIL that out, you'd have a times a, so that's a squared. Then you'd have minus a times b and then another minus a times b, so that's minus 2ab. And then negative b times negative b would be plus b squared. So what we want to do when we're factoring trinomials, we want to look for these patterns, this first and this second pattern. Okay, so let me give you an example. Let's say we have 9x squared minus 30x plus 25. So what you might notice here is the very first term, 9x squared, is actually a perfect square. If you take the square root of 9x squared, what you get is 3x. And the last term, 25, that's a perfect square. You get a whole number. You take the square root of 25, you get 5. And if you multiply the two together, so we could call this first term a, right, from right here. So that's a. And the square root of the last term is b. So we just need to see if the middle term, that 30x, is 2ab. So 2ab is equal to 2 times 3x, which is a, times 5, which is b. It'd be 6 times 5, that's 30x. So it fits the pattern of the second one, a minus b squared. You have an a squared here, so a is 3x, b is 5, and then 30x is 2ab. So we fit the pattern of this a minus b squared. So we can factor that just by seeing that it matches this pattern. All right, so what is that? It's just a minus b squared. A is 3x. And then because it's the second one, we have a minus in the center here. B is 5. And so if we're wanting to factor this trinomial, because we recognize the pattern, it factors into a minus b all squared. Let's check it. How would we check it? Well, we're going to FOIL it back out, the 3x minus 5, multiply it back out, and it should match the original. 3x times 3x is 9x squared. Then you would have minus 15x and then another minus 15x. That's minus 30x. And negative 5 times negative 5 is positive 25. So it does indeed check. All right, let's try another one. So I won't do as much explanation on this one. We'll just see, does it match the pattern? Let's say we want to factor 9x squared plus 24xy plus 16y squared. Well, if you look at it, it looks like they are perfect. The two end terms are perfect squares. If you take the square root of them, you're not going to get decimals, right? So what would A be? Well, the square root of 9x squared, we actually did that on the last one. It's 3x. And then how about 16y squared? Well, the square root of 16 is 4, and the square root of y squared is just y. Square the term, and it'll match the original. Now, does 2ab work? Well, 2 times 3x is 6x times 4y. 6 times 4 is 24, so you do have the 2ab term works out, but I just wanted to check that in my head. So this is going to factor into the first one. Since it's all positives, it would factor into a plus b squared. So that's 3x plus 4y all squared. So just give the a, give the b. Make sure the center term matches what you need it to 2ab. And we could FOIL that back out. You don't have to check it, but on a test, I would certainly suggest that you do. Times 3x plus 4y. Okay, so we're just checking this here. 3x times 3x is 9x squared. And then we've got a 12xy, another 12xy, so plus 24xy. And then the last term, 4y times 4y, would be plus 16y squared. So it does indeed check. So you can choose to work these by trial and error like we did in section 1.8. All right, so you could just draw the parentheses and try to figure it out, but you will save time, a lot of time, if you can match the pattern. All right. Well, let me erase this and we will see if we'll do one more example before we move on to the next little section. So I'm just going to all right. So let's do a little bit fancier one. So let's say we're asked to factor 2p plus t all squared plus 6 times 2p plus t plus 9. Well, believe it or not, this one actually matches the perfect square trinomial pattern. Because what would A be? Well, if you take the square root of 2p plus t all squared, you get 2p plus t. And then obviously 9, the perfect square of, or the square root of 9 is 3, so you have a perfect square. And do we have the 2ab for the center term? Well, 2 times 3, which is 6, times 2p plus t, so the 2ab matches. So it's because everything is plus, it matches this top one, a plus b, all squared. So we could just write it like this. 2p plus t plus 3, I'm going to use brackets, all squared. And you could FOIL that out. You could write it twice, FOIL it out, and you would come up with the original equation. So you might get one on your homework, 1 or 2. That looks a little bit fancier. Excuse me, I had to take a drink there. But really not too bad. All right, section 1.9.2 is factoring excuse me, the difference of two perfect squares. Okay, it's got to just be the difference. So a minus sign and two perfect squares. All right, what do I mean by that? So what we're going to be doing is factoring a squared minus b squared. Okay, so this is something for you to memorize. So I'm going to put an asterisk if you need to memorize it. All right, and you really need to memorize these two patterns here also. So I'll put an asterisk there. And it factors into, if you see a squared minus b squared, right, it factors into a plus b times a minus b. Okay, so let's give an example here. Let's say we want to factor x squared minus 4. Well, do we have a perfect square here and a perfect square here? Well, if you take the square root of x squared, you're going to get x. So a is equal to x. How about 4? Is that a perfect square? Yep. If you take the square root of 4, you get a whole number, 2. So this one factors into a plus b. Ooh, got a frog in my throat. So sorry. A plus b times a minus b. So that would be x plus 2 times x minus 2. All right. So if you FOIL that out, check to FOIL that out. So x times x would be x squared minus 2x for the outers plus 2x for the inners, and then minus 4. These cancel, and you end up with x squared minus 4. So it does check. You get back to the original. So you see the difference? It's got to be the difference of two perfect squares. It factors into this pattern, a plus b times a minus b. All right, let's do one more example, and then that'll be the end of this short lecture that I kind of turned section 1.9 into 2 lectures, so that occasionally you have a kind of a short day. All right, and we're still in 1.9.2, and our example is to factor (16x squared minus 81y to the 4th). So is this the difference of two perfect squares? Well, it's the difference. There's only 2 terms, so we should see if it works. Well, what's the square root of 16x squared? Do you get a whole number? Well, the square root of 16 is 4. The square root of x squared is x, so that's a perfect square. How about b? Well, the square root of 81 is 9. The square root of y to the 4th is y squared. So this one would factor into 4x minus 9y squared. Or it doesn't matter if you do the minus or the plus first, doesn't matter, times 4x plus 9y squared. So if you FOIL that out, the two middle terms go away and you just end up with two terms. All right. So let's have a warning here. This method doesn't work with a squared plus b squared. Remember, that was in section 1. Well, we really haven't even done that. Okay, so that method, if you have a plus there, you can't, it won't turn into this. Okay, so that's not a pattern we really have there. All right, so the homework is worksheet 1.9 and just do 1 through 10. Make sure that you, on your homework, don't just go straight to the answer. Declare on your worksheet A and B. I want to see A and B, and then you can go to the answer. Same thing on the test. All right, that does it for Lecture 1.9a, and I will talk to you on the next one.